Aside from the copy and limit transform constraints, the transform constraints also include limit distance, maintain volume, and transformation constraints. Keep in mind that all constraints and concepts in this video also apply to bone constraints. The transformation constraint is the biggest one we should talk about. This is a very powerful constraint that helps map certain transformations to affect other kinds of transformations. For example, in the copy location constraint, we can have the location of one object affect the location of another object pretty easily. Same with copy rotation and copy scale. However, if we wanted to use the location of one object to affect the rotation of another object, we wouldn't be able to do it with those constraints. These are two different transformation channels. However, with the transformation constraint, we can do just that. Let's go ahead and add this constraint to our monkey object. Now, these settings look a bit intimidating, but it's pretty simple to tinker around with once you understand what it does. The source section of the constraint settings refers to the target object settings. Here you can choose what type of transformation you want to listen to from the target object. This includes lock, rot, and scale. And the destination section of the constraint settings refers to the constrained object. Here you can choose what type of transformation to affect for the constrained object. The source to destination mapping section lets you choose which axis of the target object affects which axis of the constrained object. And the X, Y, and Z values you see in both sections is for setting a ratio of movement between each object. This is where the magic happens. So let's say very simply that we want every 10 meters of the target object's location to drive 90 degrees of the constrained object's rotation. We can do this by changing the transformation type in our constraint settings. Our source, or target object, is already set to location, so we'll make sure to set our destination object to rotation. Then we can simply change the max value of the x-axis to 10 meters for the source. And to make sure that these 10 meters will rotate the x-axis of the constrained object 90 degrees, we can change the max value of the x-axis to 90 degrees for the destination. And now, as we move our target object along the x-axis, you can see that the constrained object is rotating a maximum of 90 degrees. Now, let's say we wanted to drag our cube further while still affecting our monkey object. Well, to do that, maybe we can say every 20 meters will rotate the constrained object 180 degrees, giving us a bit more leeway. However, that's not really practical, as we'd have to go on forever, multiplying redundantly until we're confident the range is what we need. No. Instead, we can simply keep our 10 meters to 90 degrees ratio and go to the top of our constraint to check the extrapolate option. This will extend our ratio infinitely and allow us to go past the limits of the min and max, but maintain the same ratio of transformation. Now, if we wanted to have the y location of the source object affect the x-axis rotation of the constrained object, we would just need to change the source to destination mapping here. Instead of x to x, we can change this first value to y. And yes, you can have the same source transformation axis drive two destination transformation axes if you like. And then we would simply need to change the maximum y value to complete the ratio. This should give you a fundamental understanding of the transformation constraint. The limit distance constraint is pretty self-explanatory. Similar to the limit location constraint, this constraint takes the input of the user to restrict movement of the constrained object. However, additionally, it also takes in a target object to use as reference. This allows for the user input to set the max distance the constrained object can be from the target object at any time. In other words, you get to put the object on a leash. But you can also invert the effect by changing the clamp region from inside to outside. This makes it so that the constrained object cannot come within a certain distance of the target object, which makes it feel more like a force field instead. And the final clamp region option, on surface, will force the object to keep the distance a constant, not allowing it to get further or closer to the object than the distance set. The maintain volume constraint prevents objects from freely changing their scale. Typically, when scaling an object, the volume of your object gets increased for free. However, with maintain volume, it restricts you from gaining free volume, forcing your object to bend and contract while scaling, just like a real volume would if forced to change size. However, the volume input value is a world value. Therefore, you'll need to know the neutral volume of your mesh. I hope this helps you understand more of how the transform constraints work. Feel free to experiment or read more about them in the documentation in the description down below.